All right, we're going to continue looking at special patterns. So I just want to let you know we do not have to memorize these formulas. There's another way to find the answer, for example, 7, 8, and pardon my mistake here, 9 and 10. For these 4 remaining problems, we can do what we've been doing. We can just distribute or FOIL if you want to. You don't have to waste the brain space to memorize these patterns if you don't want to. So if you can inspect a problem and go, oh, that's a special case, and you remember what the formula is, these formulas right here, fine, great, good for you. But if you don't remember it, that's okay. Just continue doing what we're doing with foiling or distributing. All right, so for example 7, we're asked to multiply these 2 binomials together. The reason they're a special pattern is because we have the sum and difference of 2 terms, meaning that we have a sum, the plus sign, and a difference, a minus sign, of an x and an x that are identical and a 3 and a 3 that are identical. So if you have a plus minus, a sum difference of 2 like terms, 2 sets of like terms, the x's are the same and back behind the 3's are the same, then you can use this formula to get the answer. I'll talk us through this formula, but again, if you don't want to waste the brain space in memorizing that formula, just remember what we've been doing. You can take the first term x, multiply it into each of these 2 terms, take the 3, the last term of the first parenthesis, multiply it in here, you're going to get the same answer. It doesn't matter. All right, but if you do want to kind of look at that special case or that special pattern, this formula right here tells us that we have a sum and a difference of 2 like terms. The a's are the same and the b's are the same, whatever they are. You can get straight to the answer by just multiplying a times a and getting a squared, and multiplying b times b, or the last 2 terms in our problem, and getting minus b squared. So they're saying that you don't have a middle term like when you FOIL. So let's see what happens here. Okay, I'm going to go ahead and distribute the way we've known all along. So x times x is x squared. This product on the outside is minus 3x. The product on the inside is plus 3x. And the product of the last 2 terms is minus 9. Well, notice what happens when we FOILed. These 2 terms right here will cancel each other, because what you end up having is a minus 3x and then a plus 3x. So all we had to do was multiply the x and the x, or in this case, the a and the a, you get a squared, and then multiply the 2 terms that are in the back ends of each of the parentheses and get minus 9, because plus and minus make a minus 9. So this answer is x squared minus 9. So if you see the pattern, fine, use it. If you don't, just FOIL or distribute. Look at example B. All right, is this a sum and difference of like terms? I mean, that's kind of the first thing I noticed is like, oh, 2x squared and 2x squared are the same, 4 and 4 are the same, and I have a plus and a minus. Now, I could have had the minus up here and the plus here. It doesn't matter the arrangement. It still would fit this formula right here. So you can still FOIL the way we did before, but let's try and use this pattern here, okay? Well, I know I'm going to have some terms that cancel like I did up here. So I'm just going to multiply 2x squared times 2x squared, and I'm going to get 2 times 2 is 4. X squared times x squared gives us x to the 4th when we add the exponents. Positive 4 times negative 4 gives me negative, and then 4 times 4 is 16. So I encourage you, if you don't believe that that would be the answer, I encourage you to go back and just use the method that we've been using so far. And what you'll see is that you'll have a couple of terms that cancel, like we did here, and then all that mattered was the product of the 2 first terms and the 2 last terms. All right, this right here, okay, this is another set of formulas, and again, just like in the previous 2 examples, okay, you don't have to memorize these formulas unless you just want to. All right, first thing I see is, oh, this is a binomial squared, which if you were to expand this, all it means is that you have 2 of these that are the same. So another way to write this expression expanded is quantity x plus 3 times quantity x plus 3. So when I say quantity, think parentheses. All right? So notice that this is not the previous special pattern because both of these parentheses have the same sign. They're both adding, both pluses, whereas if I'm going to use this formula, in one of the parentheses I have to have a minus. Doesn't matter which one, okay? So they're saying that this problem right here, this example fits this formula right here. And what they did was they expanded like we did, okay? But then they went over here to the final answer, right? right, let's see if we FOIL this, we get the structure of this final answer. So we'll go back and look at the formula later. We'll match this answer that we're gonna get by using FOIL or distributing to this formula right here. All right, so down below, I'm just gonna say, okay, I've got to multiply the x into these two terms and the 3 into these two terms. So x times x, x squared. Notice you're going to get a plus 3x, and then right here, because I have the same sign, I'm going to get another plus 3x. So these won't cancel, that's why it doesn't fit the previous pattern. 3 times 3 is 9. So let's collect this, and I'm going to get x squared plus 6x plus 9. So that's my final answer. Okay, let's see if we can use the formula to avoid doing all this if you choose. You don't have to. Okay, it says if you have a quantity, parentheses squared, you can go straight to the answer, and the answer contains these 3 terms. Terms are what you add or subtract. This is your first term, second term, third term. Just like I have a first term, second term, third term. Okay, in this formula, it says if you identify a binomial square, take the first term of the binomial, which is x, and square it. Yep, that's what I got, x squared. Then this middle term, it says multiply 2 times the product of a, b. Well, what are a and b? Well, a and b are the x and the 3. So if I multiplied x and 3, I get 3x, but then I have to multiply it by 2. So 2 times 3x gives 6x. Yep, that's what I have. And then in the formula, the last term that I need is the b squared. Well, what's b? Well, in my problem, b is 3. What do I get when I square 3? I get 9. So if you can kind of remember that pattern, to get to this answer, you square the first term, you multiply the 2 terms in the binomial together and double that, multiply by 2, and then you square the last term, and that becomes the last term of your answer. All right, same thing here with this example. Okay, without expanding it, well, I am going to expand it. I tell you what, I'm going to go ahead and expand it, x minus 3 and x minus 3. You may want to just go ahead and distribute or use FOIL. But down below, I'm going to see if I can use this formula right here that gets me to this answer without having to go through all that work. Either way you want to do it. So notice that you have a subtraction. So you have 2 of the same binomials. So it's unlike these last 2 examples up here. You don't have a sum and difference of like term. You have 2 differences. So nothing's going to cancel. So let me come back up to the formula. The formula says the answer is going to contain these 3 terms. So square the first term. This term right here comes from squaring a. What is a? A is x. So I'm going to get x squared. Okay, my answer has to contain this term right here. It's negative 2 times ab. Well, in my problem, that would be x times negative 3. So negative 3x times negative 2. Oh, no. Excuse me, let me just think of this x as a, and the positive 3, not a negative 3, is b. There we go. So for this middle term, I'm going to multiply x times 3 and get 3x, but then I've got to multiply 3x times negative 2, and I'm going to get negative 6x. And then I'm going to get the last term of my answer, b squared, by taking b, which is 3, and squaring that and getting 9. So had we FOILed or distributed with our previous method, okay, we would, and collected, we would end up with this answer. So just again, if you see that there could be a special pattern applied and you remember the formulas, great, use them. Otherwise, you might be wasting time when you could just otherwise just get right to FOILing or distributing.